So let's get started. We're gonna see what is data warehousing and introduction for the data warehousing, and we're gonna see what is OLTP and what is OLAP, and introduction for ABInitio and the basic architecture of ABInitio. And we're gonna see three important components of ABInitio, GDE, DMB, and for operating system. We're gonna see them, and various components, working components of ABInitio, and lastly we're gonna see the benefits of ABInitio over other ETLs. Like in the market, we have multiple ETLs, right? So we have Informatica, we have ABInitio, and we're gonna see what is the advantage of having ABInitio over other ETLs. So yeah, let's get started. So data warehousing. So data warehousing is nothing but as the name says, it's working on data. Warehousing means the storage. So data warehousing in the sense getting the data, getting the raw data from multiple sources. Like it can be a text file, it can be a it can be a database table, or it can be a Excel file, it can be CSV file, it can be a mainframe data set, whatever. Getting a raw data from multiple sources, bringing them to the processing server, and then converting the raw data into meaningful data. Like say for example, in one of the source we have 100 columns, in another source we have 250 columns, but we don't need all these 350 columns in our database. So we'll be looking for only 150 columns, like 75 from first source and 75 from the second source. So what we're gonna do, we're gonna remove the unwanted data, bringing the raw data and converting the raw data into meaningful data, like removing the unwanted data, like making the data perfect, creating a perfect data, and then we load into the data warehouse. Like data warehouse means it's storage. Like mostly data warehouse will be built on top of RDBMS, any database, so that the data retrieval will be it will be faster. Like if you have a table, if you load the data into a table, so the data retrieval from the table will be easier. If you have millions of records, if we using the select SQL, you can just filter out the data that whichever what data that we got. So mostly data warehouse will be built on top of the RDBMS database. So data warehousing is nothing but getting the data from multiple sources, converting the raw data into meaningful data. Like we'll be doing the data transformation, data cleansing, and all this part. And once we created a meaningful data, we load them into data warehouse. So this is data warehousing part. So in the data warehousing part, we have two layers. One is the ETL layer, and next one is the presentation layer. So ETL layer is nothing but it will do extraction, it will do the data transformation, and then it will do the data loading part. So this will take care of the ETL layer. So we have multiple ETL tools. So to do this, ETL processing. So next on top of that, we have presentation layer. So presentation layer is nothing but once we load the data into a data warehouse, so we have another tool any reporting tools such as MicroStrategy, Power BI. So what it will do, it will retrieve the data, it will take the data from the data warehouse, and then it will create a beautiful report, like whatever report that business analyzer, whoever it may be, who analyze the data, right? So whatever report that they want, they can generate using the reporting tools. So this is whole picture of data warehousing. So data warehousing means getting the data from sources, doing the data transformation and load the data into data warehouse. So once the data got loaded, we have a reporting tool which will fetch the data and then it will create a reports. So this is data warehousing. So why we need a data warehouse? Why we need to store the data? Why we need to retrieve it? Means having a data, nowadays data is a it's like a modern day fuel actually. Like data is nothing but a modern day fuel. So whichever industry is having, whichever company is having more data, so they are the number one in that particular business. Like in the sense, if they have data, what they can do, they can analyze the data. Let's say for example, one credit card industry or one e-commerce industry. So they have multiple data. So what they can do, they will let's say they're in industry for past 5 years or 10 years. What they can do, they can analyze what are the different types of products that has been that are in one particular area, what is the top selling product, and in one particular area which product is not sold on that much level. So what they can do, they can analyze it. So they can analyze the data, what type of how the business is performing in one particular location, how business is performing in another location. So if it is not performing well, so having the data, having the people data, what they can do, they can get some strategical decision. They can take some decision to bring up their particular business on that particular geographical location. So based on the data, what they can do, they can they can develop their business. So that is the main goal of having a data warehouse. So data warehousing means like having a data they can analyze so that they can they can develop their business. So that is the main part of data warehousing. So, like, in data warehousing, like, whichever industry, like, wherever they have data, they will have a data warehousing for sure. Like, mostly, data warehousing will be built on banking and financial segment, like, credit card industry or banking industry. So, they will have a data warehousing. And insurance industry, they will have retail, telecommunication, airline industry, like e-commerce. So, these are the area where we have, like, a huge amount of data. So, they will have data warehousing in their architecture. So, this is all about data warehousing. So yeah, let's move on. So next is in data warehousing, we got two types of processing. One is that OLAP, and next one is that OLTP. So OLAP is nothing but online analytical processing, and OLTP is nothing but online transactional processing. So OLAP is an historical data process, but OLTP is a current day-to-day processing. And OLAP is not a real-time data, but OLTP is a real-time. Like it will have the current data. It processing the current values called as the OLTP. So let's say, for example, we have a credit card. So using that particular credit card, you're going for one particular, so you're going for a shop and you're buying something using that particular credit card. So once what they do, they'll get your card and they will swipe it and then you'll give your PIN and then once the payment is done, so what will happen? That particular machine, like that swiping machine, it might be a third party machine. So it will collect the data, like your information, your the transaction information for that particular transaction information. So all these things, what it will do, it will send it to your bank server. So in your bank server, in that particular credit card bank server, right? So in that particular server, there will be a one particular application, like there will be some code which will be running 24/7. So it will be waiting for the data. So once that particular application receives your data, like that particular transaction data, so what it will do, it will do some process, like it will do some process and then it will send the acknowledgement back to your registered mobile number, right? So this is OLTP process. So OLTP process means like it will process the current data. So whatever that data that you have swiped it for the particular transaction, so that data will get processed. So that is called OLTP process, like online transactional processing. So let's say the same banking, so same bank, the credit card bank, what they have, like let's say you're using the particular credit card for past 5 years or 10 years. So what they will have all your transaction data, like from the day one, for 5 years and 10 years, they will have your transaction data. So they know where you are using your card, where you are not using your card. So what they can do, they can analyze it. So let's say, for example, you have not used that particular credit card in Amazon or Flipkart. So what they will do, they will analyze it. They will come to know that you are not using this card for some e-commerce site. So what they can do, they can come up with some decision. Like they can give you some offers. They can give you some vouchers to make you to use that particular credit card to buy something in Amazon or Flipkart. So by that way, they're developing their business. Like they're generating the business. So that's how, like that is OLAP process. So OLAP process means having the historical data, processing the historical data, and they based on that they can develop their business. So that is OLAP process. So this is the difference: OLAP process and OLTP process. Like both are data processing, but that's the difference. Like OLTP means it will process current data, like real time data. But OLTP it will process OLAP it will process the historical data. Yeah. So OLTP, it should have high performance. Let's say, for example, you swipe your credit card and you should get that SMS alert within few seconds or within a minute. So like within no time, that processor, that whatever application that's running, that it should process your data. Within no time, it should send the acknowledgement back to a registered mobile number. But OLTP, it should be highly flexible since it has to handle millions of records, right? So it should be highly flexible. And yeah, OLAP will have millions of records. And since it's processing historical data, the number of records will be more in OLAP. And for OLTP, the number of records will be few hundreds or in total because like it will process only the transaction, right? Particular transaction data. So number of records will be much more smaller in OLTP process. So there is a difference. Like we have OLAP and OLTP. So in ABInitio, we have both the process. Like we have both OLTP and OLAP. OLAP we used to call it as a batch processing, and OLTP we used to call it as a continuous process. So continuous process in the sense like that particular ABInitio code will run 24 by 7. Like it will keep on running. So it will wait for the data. Once it receives the data, it will process the data, and then again it will keep on waiting for the next data. So that is continuous process. So we got both OLAP and OLTP process available in ABInitio. So yeah, let's get move on. So next, yeah. So this is a basic architecture of ABInitio. So we have a GDE and we have a pipeline system and we have an ABInitio. So yeah, GDE. So first one is the GDE. So GDE is nothing but a graphical development environment. So in ABInitio code, we used to call it as a graphs, ABInitio graphs. So graphs, GDE is a front-end user, user front-end UI tool. So let's say it will be installed on our local machine, wherever you're working, right? Our desktop or laptop, so wherever you're working. So this particular application, software will be installed on our local machine. So this is GDE. So here in this GDE, we can develop the graph. GDE is for GDE means GDE stands for graphical development environment. So here using this GDE, we can develop the graph. So graphs is valuable. Abnisho code is nothing but we don't have to write lines and lines of code. Abnisho code is nothing but it's already it's a pre-built components will be there. So what we have to do, we just need to drag and drop the components. We have to. This is the GDE. So we have multiple components over here. We just need to bring the components here, and then we need to graph is nothing but multiple components, and each component connected by a flow, and then for each component we need to provide the parameters, parameters in the sense the for each and every component we need to provide the parameter. So that is a graph actually. So let's say for example we have a graph, we have a graph here. So what it will do, this is an input file component. So what it will do, it will read the input file, and then it will sort the data, and then it will filter some data, and then it will write some output data. So let's say we need, we have the graph, this is the skeleton of the graph. So here we connected the flow as well. So, but we need to provide the parameters. Let's say, for example, there will be in that particular server, there will be multiple files will be there, hundreds and thousands of files will be there. So which file should ABInitio read? We need to tell ABInitio which file it has to read. So here we need to provide, you have to open that parameter tab. You have to properties tab. You have to go there, and here we need to provide URL, URL in the sense the location of that file. We need to provide the location of that file, directory of that file, and then the file name. So we need to provide the file name over here, and then we need to provide next is for that file component we need to provide the record format. Let's say for example if you open that file, let's say if we have a text file, and if you open that file, Abnisha should know how to read that file. For example, let's say we have 100 records and 100 records, and each record is having 10 columns. 10 columns and 100 records. So how application should read? So from first character to till what character, which should take it as a first column. From which character to which character, it should take it as a second column. So we need to provide that particular record format for Abnisho to read the file properly. So let's say, for example, if it is a first name, last name, what we can do, let's say if it is a comma separated file, if it's a CSV file, what we can do, we can provide starting from the first character, and whenever it encounters the first comma, take it as the first column, and the data from the character next to the first column, on the character till the second column, take it as a second comma, take it as a second column. So we have to provide, if it is CSV, we need to provide the record format like this, or else let's say if it's a fixed length DML, fixed length in the sense first 10 characters, take it as a first column. 11 to 20, take it as a second column. And then 21 to 30, take it as a third column. So like this, we have to define it, based on our requirement, we have to define it. So basically, we need to tell Abnisho which file it has to read, and then how to read that particular file. So this is a parameter needed for this input file component. Same way for output file component, we need to provide where to write the file, what file name should, if the file is not there, so what it has to do, it has to create a file, and then in one particular name, in one particular location, it has to create a file, and then it has to write the data. So there we need to provide the same record format as well as the file name and the location. So these are the parameters, right? So for each and every parameter, for each and every component, we need to provide the parameters. So let's say for sort component, we need to say on based on which column it has to sort. Either it has to sort it on ascending sorting, or we have to do it in a descending way. So we need to provide these kind of parameters. For each and every component has its own set of parameters. So we need to provide. So based on the parameters, this initial graph will execute during the runtime. It will behave during the runtime. So this is GD. So GD is where we can create a graph, where we can create an ABInitio code. So using this GD, we can create a graph. we can test it, we can debug it, we can trace the execution log, we can see how many records flown from one component to other component. If something got rejected, so you can see how many got rejected. So it's like a overall picture. It's like a only way we can access to ABInitio, like from where like it's a user interface. So this is GD. So whenever we save a graph, this particular code will be saved with .mp extension. So yeah, so this is GD. Next is corporate system. So corporate system. So corporate system is nothing but it's a OS. It's like a ABInitio based OS. So let's say for example, like most of the mostly 99% the processing server will be a Unix system. So we have already a Linux or Unix OS. So on top of it, we'll be installing this corporate system. It's like an ABInitio based operating system. So this operating system will act as a mediator, between the ABInitio code and then the native OS, Unix or Linux OS. So it will convert the ABInitio code into native OS understandable language. Okay. So it acts like a media, it's like a backend for the ABInitio. So most of the mostly like we don't have to do anything with the operating system. What we have to do is just we have to get the latest version. Whenever there is a ABInitio Corporation will release the multiple versions. If there is any bug, they will release the next version. There is a version number will be there. So whenever it releases a new version, we need to get it. We need to get the latest version, and we need to just install it. So it's just an OS. It's ABInitio based OS. Next is EME. So EME is nothing but enterprise meta environment. So enterprise meta environment. So EME is nothing but it's like a source code control. It's like a repository where we can store the different versions of the ABInitio code. Let's say, for example, today we develop a graph. Like say in a project we develop a graph. So what we can do, now we got a brand new requirement. We develop a brand new graph and we deployed in production. So now let's say after 6 months, client is saying they want to have some more feature. So they want to add some more feature on that particular ABInitio graph. So what we'll do the code changes and then we'll promote the code again to production. Let's say for after a month, the client is saying that they don't want that latest version of the code. Whatever feature that we have added, they feel it's not correct. So what they want the previous version of the code. So what we have to do, we have to manually remove the whatever code that we have changed. So we have to manually do the changes again. So instead, what we can do, like if you have the latest version, previous version available, we can take it from there, right? So from there, like for this purpose, we have an EME. So EME is nothing but it's like a source code control. It's like a repository where we can store the different versions of the ABInitio code. So let's say, for example, today we develop a graph and then we deployed in production. So we have one copy, we will have one copy in the EME. So EME is nothing but it's a different, it's another server where we store the different versions of the ABInitio graph. So let's say the first graph will be saved as a version number 1. So let's say after 6 months, we are doing some changes, right? That particular version will be saved as a version number 2. Then here in EME we'll have two versions, version number 1 and version number 2. So current code in production is version number 2. Let's say after a month, client is saying that whatever changes that we did in version number 2 is not correct. They need the previous version. So instead of doing the code change manually again, so what we can do, we can simply take the version number 1, which is already available in the EME server, EME server. So whenever we push the code into EME, it will save it as a different version number will be there. So based on that version number, we can pick and choose. If you want previous version, we can using that version number, we can get that code. And so this is the main purpose of EME. So EME is nothing but it's like a repository. Okay. So now let's say for example there is a folder called sandbox. So sandbox in the sense it's a user space. If I'm a ABInitio developer, I will have my own sandbox. If some other person is working on my time, so he will have his own sandbox. So let's say today I'm developing a graph, and if I saved it through GDE, I develop a graph, and if I save it, that particular graph will be saved in my sandbox. And same way, if he develops a graph, if he save it, it will be saved in his sandbox. So every person will have their own sandbox. But the EME is a common repository. Whoever person working on that particular project will have access to that particular. It's a common same folder structure. Whatever we have in Sandbox. So same folder structure will be available in the EME. So EME is common for all, but Sandbox, every individual person will have their own Sandbox. So now, now if I want to move the code from my Sandbox to EME, so that process is called check-in process. Let's say if I want to take the code, if I want to move the code from EME to my Sandbox, that is called checkout process. So we have two processes here, code movement process. I'm saying, if I want to if I want to push the new code into EME, so that is called check-in process. Or if I want to get the existing code in EME to my Sandbox, that process is called checkout process. So yeah, this is all about EME. Next is components. So yeah, so in ABInitio we have multiple components which are there. First is the dataset component. So dataset components, using the dataset components, we can read the file or we can write the file, or we can read the data or we can write the data. Let's say if you have a input file and output file component. So if you have an input file component, using that we can read a text file, and if it is an output file component, we can write a text file. Let's say, for example, if our source is a table, so we have a input table component, and if you want to load the data into a table, we will have an output table component. So like this, we have a different set of data set components. And next is the transform component. So we have these are the main blocks of ABInitio, where we'll be doing the real data transformation. So we got multiple transform components available. So let's say we have a reformat component, join component, sort component, dedupe sort, preserve expression, normalize, denormalize. So we got multiple components or transform components here. So these each transform components will have their own set of parameters. So that's what we're gonna see in the upcoming sessions. We're gonna take each component and one particular each we will be taking one component and we'll see what are the different types of parameters that particular component needs, and how to give parameters to that particular component, and then how that particular component behaves during the runtime with using that particular parameters. So this is what we're gonna see in the upcoming session. So let's say once we are into the real world, once we if you are into a project, we'll not get a requirement saying that use this component and get this data like this. We don't get any kind of requirement like that. What we usually will get it we'll have an input data set of input. This is what our input file will look like, and this is what output that we need to create. So meanwhile, we need to pick and choose. We need to know different types of components available in ABInitio. So to achieve that particular output, we got once set of input we have. So using that input, I need to achieve that output. So what component that I have to use to get that particular result, right? So we need to pick and choose. So do that. So to get that, we need to know the runtime behavior of each and every component. So we need to know okay, for this particular requirement, for this particular work, I need this component. So this component will help me to get this achievement. So for that, we need to know the runtime behavior of each and every component. So that's what we're gonna see in the upcoming session. So yeah, so these are about transform components. Yeah, before getting in, let's see the benefits of ABInitio. So one of the main benefit of ABInitio or other retail tool is it supports parallelism. So parallelism is nothing but processing the data parallelly. So there are three types of parallelism available in the in ABInitio. One is the data parallelism, next one is the component parallelism, and third one is the pipeline parallelism. So, so first one is the data parallelism. So data parallelism is nothing but processing the data parallelly. So let's say, for example, we have one file, we have one file, and that particular file is having 100 records. And to process that 100 records, one file having 100 records, ABInitio is taking 100 minutes. So now what we're gonna do? We're gonna split that one file having 100 records into four files, each having 25 records. Now what we're gonna do? We're gonna process the four file parallelly. So let's say first record from the first file, first record from the second file, first record from the third file, and first record from the fourth file. So all these four records gonna get processed parallelly. So by this way, we can process the whole 100 records in 25 minutes. So using this way, in yearly one, in the serial one, we got to process that 100 records, ABInitio took 100 minutes. But here, by splitting the data into multiple files, and if you're processing using that, like ABInitio will be able to process the data in 25 minutes. So here we save 3/4 of the time, right? So this is what parallelism means. Like we are processing the data in much more quicker time. So to achieve that, to split the data, to achieve the data parallelism, there is a concept in ABInitio called multiple system. So to achieve that multiple system, we'll be needing this partition and departition components. So this partition component, so what it will do, it will convert the single serial file into multi-file. So multi-file is nothing but one file. We physically split that one file into multiple files, but all these multiple files, we logically group them as a one single file. So, but physically, if you open that file, if you say it physically, there will be four different files will be there. But these different files will combine, we logically combine them, and on the whole, we will see it as a multi-file. So to achieve that, to convert the serial file into multi-file, we will be using this partition components. So partition components, there are multiple partition components of the partition by key, partition by round robin, partition by range, expression, and rollback. So it will different types of partition components. The way of data partitioning will be different on all these type of components. We're gonna see in the session, right? In the upcoming session, we're gonna see. So we need to know how the data should get partitioned. So based on that, we can pick and choose which partition component that we need to use. So next is departition component. So departition component, it's like a vice versa. So in partition component, we convert the single serial file into multi-file. But departition components, if you convert the multiple file into serial file. So there are four departition components available in like ABInitio. One is that concatenate, merge, gather, and interlink. So this is partition and departition components. So using this partition and departition components, we can achieve data parallelism. So next one is the component parallelism. So component parallelism means like if multiple components on the multiple components on the same graph, if it can execute parallelly, then that is called component parallelism. And third one is a pipeline parallelism. So pipeline parallelism is like if we have the same flow in the graph, we have in the same flow. If we can allow multiple components to execute parallelly, then that is called pipeline parallelism. So these are the three different types of parallelism that we have in ABInitio, and it is one of the main advantage of ABInitio over other utilities. In other utilities, we don't have these parallelism concept. The way to process the data in quicker time. And yeah, so ABInitio is a very powerful ETL tool. It can handle multiple data. Like it can handle multiple set of data. It can handle Hadoop files, HDFS files. It can process Java files. It can process JSON file. It can process mainframe files. It can process all types of it's very uh, yeah, it can process a heterogeneous set of files, multiple different set of files, and it can handle huge number of records. If you have millions of records, it can, ABInitio can handle it, and we have a better support system, and most of the banking does, almost 99% banks in US and Europe and Australia is using ABInitio. Almost every bank in these countries are using ABInitio, and using ABInitio can have very high performance, and it's very robust, and it's very scalable. We can build very heavy transformation using this ABInitio.